In this video, we'll learn about something called a conjugate, and we're also going to learn how to multiply complex numbers. Now again, just think of complex numbers or I as an x, first of all. So if I want to multiply these two complex numbers, again, think of it as an x. So what would you do in this case? Now, as you can see, there's nothing between the two numbers, so I'm not adding, I'm not subtracting. So basically, I am multiplying, so there's a dot over there. Now, in order to FOIL, you just take the -3 and you multiply it by 7 plus 4i. And then you take 12i and you multiply it by 7 plus 4i. So again, think of I as an x. -3 times 7, let's distribute. So that's a -21. -3 times 4, that's a -12i. 12 times 7, that's 84i. And 12 times 4, that's 48. Now remember, when you multiply x by x, what do you get? X to the power 2. So when I multiply 12i by 4i, so I times I, you get an I squared, just like x. Now after we FOIL, we combine like terms. So -21 is just -21, there's nothing else to add to it. -12i plus 84i, so -12 plus 84, that's a 72i. And now let's copy down the 48i squared because there's nothing else to combine it with. So my first step is to FOIL. My second step is to combine like terms. So let's move on to the steps. So FOIL and combine like terms. And step 2, remember the big idea is that I squared is equal to -1. Keep that in mind. So every time you see an I squared, think of it as a number. So instead of I squared, I'm going to replace it by a -1. So the plus 48 times a negative, it will become a -48. So the 48i squared becomes a -48. So the I squared is a negative, it changes the sign. So instead of the plus, it becomes a minus, okay? So -21 plus 72i, and 48 times -1, that's a -48. Now we have real numbers I can combine, so -21 and -48, that's a -69. So let's review the steps, and that's the final answer. Every time you are multiplying, so there's no addition, no subtraction, basically you're multiplying, you FOIL. After you finish FOILing, you think of I as an x and you FOIL. You combine like terms. So I combine the I and the I. Keep changing I squared to -1 to the last step. Once you see an I squared, you know that you're going to change the sign of plus 48 and it's going to become a -48. Now you have like terms that you need to combine, and that would be your final answer. So take a minute and try number 11 on your own. 8 times 11 is 88. 8 times I is 8i. 15i times 11, that's 165i. And 15i times I is 15i squared. Don't rush and change I squared to a negative. Wait. 8i and 165i, these are like terms, so I can combine them to get 173i. And let's copy everything down. Now remember, the I squared is basically a -1, so it will change the sign of 15. It's plus 15, so it becomes a -15. Now let's combine the real numbers, 88 and -15. So 88 minus 15 is a 73, and you copy down the imaginary part, which is 173i. That's it. Now let's move on to number 12. 2 minus 3i squared is basically 2 minus 3i times 2 minus 3i. So again, we FOIL. So write it twice if there's a square. 2 times 2, that's a 4. 2 times -3i, that's a -6i. -3i times 2, that's another -6i. -3 times -3, that's a 9 I squared. Combine like terms, so negative 6i and negative 6i, that's negative 12i. Move the 4 down. Now remember the I squared is basically a negative. So it's going to change the sign of the plus 9. It's becoming negative 9. 4 minus 9, that's a negative 5. And copy down the imaginary negative 12i. That's it. So what happened? Every time I multiplied a complex number by another complex number, what did I end up with? So that's a complex number. That's another complex number. And that's another complex number. So every time I multiply two complex numbers, what do I get? I get a complex number. And that's how you multiply complex numbers. Now, what is a conjugate then? The conjugate is a complex number basically, where you just take the imaginary part and you do the opposite. So for example, if I give you 2 plus 3i, so let me write it down, 2 plus 3i, what would be the conjugate for that? I keep the real number as it is, but the imaginary number, I take the opposite. And we call this then the conjugate of 2 plus 3i. Okay? So let's move on to 16a and b. Let's do that first. So find the conjugate of each number. Now the real number, I'm going to keep it the same, but the imaginary, I'm going to take the opposite. Minus 3i. The same thing for b. I'm going to keep the real number, and the imaginary, I'm going to take the opposite. This is how you create the conjugate for complex numbers. So what happens if I add two complex numbers? So remember it's a plus, so drop the parentheses. So I'm adding a complex number to its conjugate. So as you can see, the real number is the same. The imaginary number, they're opposites, okay? So 6 plus 6, let's combine like terms. That's a 12. And negative 4i plus 4i, so that's a 0, that cancels out. So every time you add a complex number to its conjugate, what will you get? 12 is a real number, so you get a real number because the imaginary numbers will cancel out. Now what if you subtract them? Remember, since this is subtraction, I need to distribute. So I'm going to copy the first one down, and I'm going to change the sign of the second one. And now let's combine like terms. 6 and minus 6, that will cancel out. Negative 4i and negative 4, that's a negative 8i. So that's an imaginary number. So when I subtract a complex number and a conjugate number, I will end up with an imaginary number. The real numbers will cancel out. Now what happens if I multiply a complex number by its conjugate? So let's FOIL and see what happens. 6 times 6, that's a 36. 6 times 4, that's a 24i. Negative 4i times 6, that's a negative 24i. And negative 4 times 4, that's a negative 16i squared. So let's combine like terms. 36, I'm going to copy it down. 24i and minus 24i, that will cancel. Now I squared, remember, is a negative, so that's going to change the sign of the number in front of it. So negative 16 will become a plus 16. If I add these two numbers, I will get a real number, 52. The imaginary number is canceled out. So every time I multiply a complex number by its conjugate, I will end up with a real number. So remember, the conjugate is basically a complex number having the same real number, but the imaginary numbers will be opposites. So let's review. Every time I add a complex number to its conjugate, I will get a real number. If I subtract them, I get an imaginary number. And if I multiply them, I get a real number. And this is what conjugates are.